Welcome to this explainer. Look, if you're laser focused on maximizing efficiency and staying competitive in the 2026 manufacturing landscape, well, you're absolutely in the right place. Today, we're diving deep into the mechanics and the economics of CNC plasma tables. We're going to look at the exact hardware choices that dictate long-term profitability. Whether you're sourcing machinery domestically or looking at global suppliers, understanding how these systems actually work under the hood is no longer just a technical requirement for operators. It's a strategic, bottom-line necessity for anyone making procurement decisions.
Here's our agenda for today. We're going to break this down into 5 key sections: the physics of plasma, brains and muscle, entry-level versus industrial grade, the secondary finishing trap, and finally, total cost of ownership. Let's get right into it. Section 1. The physics of plasma, turning gas into a tool.
Okay, before we even touch the machinery, the motors, or the software, we really need to understand what this arc is actually doing. We are dealing with an absolutely mind-blowing scale of energy here, 25,000 degrees Celsius. That's roughly 45,000 degrees Fahrenheit. Just to put that into perspective for a second, that is literally hotter than the surface of the sun. So we aren't just cutting metal here, we are instantly vaporizing it. But how on earth do we harness that kind of extreme, chaotic heat and turn it into a precise manufacturing tool?
Well, that brings us to the definition of plasma itself. It's the fourth state of matter. Basically, the whole process starts by forcing a gas, like compressed air, oxygen, or nitrogen, through a tiny constricted nozzle at incredibly high pressure. At the exact same time, the machine shoots a powerful electrical arc into that gas flow. This electrical energy ionizes the gas, transforming it into a high-temperature plasma arc. This arc melts the metal in an instant, while the sheer velocity of the gas just blows the molten material away, leaving behind a clean gap, which in the industry we call the kerf. Oh, and here's a massive takeaway for anyone evaluating suppliers right now. Definitely look for a pilot arc feature. A non-touch pilot arc lets the torch ignite without physically striking the metal workpiece. It seems like a tiny detail, but trust me, it prevents a tremendous amount of wear and tear and dramatically extends the lifespan of your consumable parts.
Section 2. Brains and muscle, core components.
You know, a CNC plasma table is really an integrated ecosystem. It's a finely tuned machine, and if even one single component is underpowered, the return on investment for the whole system just tanks. There's a huge hardware divide in the market right now. On one side, you have your standard entry-level requirements: stepper motors, round guide rails, basic air plasma, and simple cam software. But on the other side, you've got the high-performance industrial standard: AC servo motors, linear profile rails, high-definition oxygen plasma, and integrated nesting software. This comparison is basically your roadmap. It shows you exactly where your money goes when you upgrade from a hobbyist machine to a serious heavy-duty production asset. Let's break down what these components actually do.
But wait, before the machine moves even a fraction of an inch, it needs instructions. For a buyer, wrapping your head around this software chain is absolutely crucial because compatibility issues here, they're the #1 cause of post-purchase downtime. It all starts with CAD, where you draw your 2D part. Then it moves over to CAM, which figures out the toolpath and uses nesting to pack parts tightly together so you don't waste scrap metal. After that, the post-processor translates all of this into G-code, the universal language of CNC. And finally, execution, where the machine actually moves the gantry and fires the torch. Look, if your software ecosystem isn't completely seamless, your 25,000-degree tool is basically just a very expensive paperweight.
So the component that actually handles all that G-code is the CNC controller. Think of it as the brain of the operation. Now, in 2026, most industrial-grade tables use dedicated programmable logic controllers or highly robust PC-based systems. But the feature you absolutely must look for here is look-ahead logic. It's kind of like driving a sports car, right? If you approach a sharp 90-degree turn at 100 miles an hour, you're going to slide right out. Look-ahead logic actually reads the G-code ahead of time and smoothly decelerates the torch before tight corners. This entirely prevents those incredibly costly rounding errors on your parts.
And if the controller is the brain, while the plasma power supply is definitely the muscle. This dictates exactly how thick of a plate you can cut and how long you can keep cutting it. Modern systems rely on IGBT inverter technology, which is incredibly energy efficient and gives you a hyperstable arc. But the absolute most crucial metric to keep your eye on is the duty cycle. For bulk buyers aiming for 24/7 continuous production, a 100% duty cycle at your required amperage is completely non-negotiable. If it's anything less, the machine literally has to stop to cool down, bringing your entire production line to a grinding halt. Nobody wants that. Section 3.
Entry-level versus industrial grade. The precision divide.
All right, this is where hardware choices directly impact your final product quality. We are looking at the mechanical showdown between entry-level setups and heavy-duty manufacturing necessities. Let's talk about motion and framing. Entry-level machines often use bolt-together kits with stepper motors and belt drives. The problem with that? A lightweight bolt-together frame vibrates aggressively at high speeds. That vibration transfers straight to the torch, leaving these jagged chatter marks all along the edge of your cut metal. Industrial motion, on the other hand, relies on fully welded, stress-relieved steel frames combined with AC servo motors and helical rack and pinion drives. This setup provides the immense torque and absolute rigidity you need to glide a torch smoothly over heavy industrial plates, ensuring a flawless edge every single time.
Speaking of a flawless edge, we really have to talk about torch height control, or THC. Honestly, this might be the single most overlooked component by first-time buyers. THC automatically maintains a constant, ultra-precise distance between the torch tip and the metal plate. Why is it such a big deal? Because industrial metal plates are almost never perfectly flat. They warp, they wave. Without automated THC constantly adjusting the height, the torch is going to either move too far away and lose the cut entirely, or violently crash into the steel plate, destroying your consumables and completely ruining the part. So yeah, automated THC, absolute must-have.
Section 4. The secondary finishing trap. Okay, this is where we uncovered the hidden labor costs that can absolutely destroy a facility's profitability. You're going to see the term high definition or HD plasma thrown around a lot by suppliers. But what actually defines it? Well, traditional plasma tables create a slightly tapered cut, meaning the top of a cut hole is just a little wider than the bottom. High-definition plasma solves this by using highly advanced vented nozzle technology. It intentionally swirls the gas to constrict the arc even further, focusing all that energy into a perfectly straight, laser-like column.
Now, yes, HD systems definitely require a larger upfront capital investment. There's no getting around that. But the result of that constricted arc is square edges, virtually zero dross, and the ability to cut perfectly straight, bolt-ready holes right there on the table. If you use standard plasma, your team has to pull those tapered, messy parts off the table and spend hours, literally hours, manually grinding the edges and using drill presses to fix the holes. By choosing HD hardware right from the start, you completely eliminate the trap of secondary finishing. You aren't just buying a better cut, you're reclaiming thousands of hours of incredibly expensive manual labor.
Section 5. Total cost of ownership. Because the initial purchase price, that's really just one piece of the puzzle. Let's look at the very bottom of the iceberg, what it actually takes to keep this machine running day after day. First up, fume management. Plasma cutting generates a massive amount of smoke, dust, and sparks. You basically have two choices here. Water tables, where the metal sits above a tank of water, are incredibly cost-effective. They trap dust, catch sparks, and keep the metal cool to reduce warping. But, full disclosure, they are a total mess to clean out once they fill with slag. Downdraft systems, on the other hand, use high-powered fans to suck the smoke into a specialized filtration unit. They are vastly cleaner for your operators and absolutely essential if you're cutting materials like aluminum, but they do come with heavy installation costs for ducting and expensive ongoing filter replacements. It's your classic trade-off between upfront capital and ongoing maintenance.
If you're actively sourcing a machine right now, consider this your ultimate procurement checklist. First and foremost, beware of the proprietary trap. Some manufacturers will sell you a super cheap machine, but then lock you into using their proprietary torch, which means you can only buy highly priced consumables directly from them. No thanks. Always demand industry-standard torches like Hypertherm or Kelberg, where you can source consumables globally. Furthermore, make sure your supplier provides wiring diagrams in your native language, highly detailed cut charts for speeds and feeds, and robust remote diagnostic capabilities. That way, if something goes wrong, they can literally just log into your controller and troubleshoot without having to fly a technician out to your shop.
Finally, we have to talk about budgeting for the machine's daily appetite. Depending on the metal you're cutting, you might need specialty gases like oxygen, nitrogen, or even argon-hydrogen blends. You also need to verify that your facility's power grid can actually handle the massive peak amperage draw when that inverter kicks on. And remember those consumables we talked about earlier? Budget realistically for them. A single shift operation can easily burn through $50 to $200 a week in electrodes, nozzles, and swirl rings. It adds up fast.
I want to leave you with this final provocative thought. When you're evaluating CNC plasma tables in 2026, the question isn't just how much does this machine cost? The real question you need to ask yourself is, are you buying a cheap machine or are you buying expensive labor? By investing in industrial-grade framing, look-ahead controllers, and high-definition arcs, you aren't just cutting metal. You're cutting out the vibration, you're cutting out the downtime, and most importantly, you are cutting out those secondary finishing costs that slowly bleed your profit margins dry. So choose your hardware wisely. Thank you so much for joining me for this explainer, and keep learning.